Okay, so welcome back. So let's do another arc length problem, but we're going to use Simpson's rule. So let's say we want to estimate the arc length, or the length of the curve of this function over the interval from 1 to 4, and we're going to use S6. Okay, so again, remember the formula for the arc length. So it's going to be, in this case, from 1 to 4, and it's the square root of 1 plus f prime of x quantity squared dx. Okay? Now in this case, it's going to be the derivative here, y prime equals, oh, we don't need the dx, equals x. Okay? So in this case, it's going to simplify to 1, 4, and this will be 1 plus x squared. Okay. Dx. And so now, this is the function we have to integrate. We have to integrate this. So now we're going to use the S6 to approximate this. So let's first start by finding our delta x. So in this case, we're doing b minus a over n, which in this case is 4 minus 1 over 6, which will equal 1/2, right? 3 over 6. And so that means our intervals are going to be what? By a half, right? So it's going to be, goes from 1, 1.5, 2, 2.5, and so on. So what are the endpoints that we're going to be using for this? It's going to be 1, 3/2, 2, 5/2, 3, 7/2, and 4. Okay, now I didn't write out all the subintervals just for the sake of time and room, but these are the endpoints, right? These are the endpoints that we're going to be using, right? That's what we use for the Simpson's rule. So we're going to use the first 3, and then the second 3, and so on, right? But again, remember the rule. So those are what we're going to use. So this is going to be x0, x1, x2, x3, x4, x5, and x6. Okay? So let's use our Simpson's rule and figure out what x6 is going to be. So now delta x is 1/2. So again, this is going to be 1/2 divided by 3, which is going to be 1/6. So now it's 1/6 times, now it's going to be f of x0 plus 4 f of x1 plus 2 f of x2 plus 4 f of x3 plus 2 f of x4 plus 4 f of x5, and then finally plus f of x6. Okay, and that's what we have. Now, this is then going to be what? 1/6 times, well, now we're going to evaluate this at each one. And this is going to be 1 plus x0 squared plus 4 times the square root of 1 plus x1 squared plus 2 times the square root of 1 plus x2 squared plus 4 times the square root of 1 plus x3 squared, and so on. Okay? And then what you have to do is you just have to plug in these values here and then use your calculator. So this is one that I would definitely use the calculator, okay? So you'd calculate each one of these in your calculator and then sum them up and divide by 6. And if you do that, you get an approximation of what? You get 8.14594. Oops. Okay, and that's it. Okay, so now, here's one for you to work on. Well, let's do okay. And then if you want to do S6, see how good it is, go for it. But again, practice makes improvement. Okay, so next I'm going to introduce the error bound, the theorem for error bound, because for using Simpson's rule, there's also an error bound formula as well. So, but we'll discuss that next time and do some examples.